Today we're going to talk about tangent, and the tangent function is not used as frequently as sine and cosine, and as you know, we said that sine and cosine are probably the two most important circular functions. But we do need to talk about the third trig function, which is tangent, and then tomorrow we'll talk about the other three. So remember at the beginning I said that there were 6 trig functions. Okay, so you may recall from geometry that the definition of tangent is the ratio of the side opposite over the side adjacent in a right triangle, since we are talking about right triangles. So let's take a look at exercise 1, and we have 2 right triangles. We're going to do A, which has the missing leg being 3, because we know this is a 3, 4, 5 Pythagorean triple. So sine would be the opposite over the hypotenuse, and then cosine would be the adjacent, which is the 4, over the hypotenuse 5. And then lastly, we have to worry about finding the tangent, and the tangent of theta is opposite over adjacent, or 3/4. Okay, so remember, you're using sine, cosine, and tangent when you're dealing with right triangles, and so you want to kind of position yourself at theta, so then you're able to evaluate the ratio of the sides. All right, I'm going to ask you to pause the video and complete letter B. This should look familiar based on the work that we've been doing in class for the past several days. Okay, now that you've completed B, we're just going to talk about a couple of things, and we're going to try another example. So obviously we can find the missing sides of a right triangle using the Pythagorean theorem. Some of you just use your ratios that you remember from geometry, whatever is comfortable for you. But just as we looked at sine and cosine in the unit circle, we can define tangent in terms of the unit circle as well. So there's a picture here. We have some angle drawn in standard position with the terminal side in the first quadrant, and on the circumference of the circle we have point P, which has coordinates x, y. And so xy represents the point on the circle. We can define tangent in terms of it because tangent is your opposite over adjacent, right? So in this case, we have just to worry about the y over x. So that leads us to quickly review the fact that we can define tangent in terms of sine and cosine, right? Because we said that the sine value is the y value, and the cosine value is the x value, because sine represents the side that is opposite, which is the y, and cosine represents the adjacent side, which is the x value. Okay, so I'm going to highlight that and circle it because this is one of the important identities that we will use as we progress in this unit. Okay, so, and then of course the definition is defined on the next page for you. Tan is equal to sine over cosine. Okay. All right, we're going to try a quick example 3. Basically, we're going to do what we've been doing for the past couple of days in class, except we're going to use tangent now. So we're still going to do the same kind of thing. If we take the tangent of 60, we're going to identify, okay, which quadrant am I in? So 60 would be in the first quadrant. And we don't really have to worry about the reference angle because 60 degrees is already positive and acute. So our reference angle is the same as the angle that we're looking for. So we said we're in quadrant 1, reference angle is 60, 30, 60, 90, or 60, 30, 90 triangle, as if it were in the first quadrant position. Okay, and we can label our sides. The side opposite 30 is half the hypotenuse, and you can label this any of the ways we've discussed. So you have x, 2x, and x radical 3. You have 1, 2, 1 radical 3. whatever is comfortable for you. You can also use the fact that the hypotenuse would be 1, and so then you can say the side opposite 30 is 1/2, and then the side opposite 60 is 1/2 radical 3, or radical 3 over 2. So any of the methods are fine. I'm just going to show you with what we learned from last year in geometry. Okay, so you're at the 60. You're using that as your reference angle. We're finding tangent, so that means we have opposite over adjacent. So radical 3 over 1 is just radical 3. Okay, I'm going to ask you to go ahead and complete B, C, and D, and we're going to kind of talk about D below in just a moment. Okay. All right, welcome back. Thank you for pausing the video to complete B, C, and D. Now, because tangent function does involve division, there is the possibility of undefined. And as you know from the last chapter, the last unit, undefined is division by 0. So fractions are undefined when we have a 0 in the denominator. Okay, so let's consider the quadrantal angle 90 degrees, and this was talked about in the video from last night. So we have this quadrantal angle, and we have a unit circle. Sorry about the not well-drawn circle there. And so we have a point on the circle that's also on the positive y-axis, and that point has the coordinates 0, 1. So the sine of theta, or the sine of 90 in this case, would be the y value. And the cosine of 90 would be the x value. So if we were to try to evaluate the tangent of 90, that would be the same as saying the sine of 90 over the cosine of 90, which means that we would have 1 divided by 0, which of course is undefined. We can't have division by 0. Okay, I want you to consider for exercise 5, at what other angles is tangent undefined? So at which other quadrantal angle would tangent be undefined? It shouldn't be undefined at any of the others because we always have a value for sine and cosine at the angles within the quadrants. Okay, the last thing we're going to review is how to find the missing trig values given a piece of information. So with exercise 6, it's asking you to determine the value of cosine and tangent if you know that sine is 5/13 and sine is in quadrant 2. So we have our angle in standard position, and we're going to draw that terminating or terminal ray in quadrant 2. Okay, we're creating our right triangle. We don't know what our angle theta is, and quite frankly, it doesn't matter because we already know the ratio of the sides. So we have opposite over hypotenuse, and so we need to find the missing side. We need to find the x value in order to evaluate cosine and tangent. Well, how do you do that? You're dealing with a right triangle, so we can use Pythagorean theorem. X squared plus y squared equals 13 squared. Okay, I'm going to ask you to go ahead and finish solving the Pythagorean theorem and find your x value. And then once you find your x value, then I'm going to ask you to go ahead and define cosine and tangent. Now, you do have to remember that you are in quadrant 2. And in quadrant 2, we said that sine is positive and its reciprocal function, which we'll talk about tomorrow. So that means that cosine and tangent, you have to consider their values.